And then this is I know. This one is your R equivalent. The trick is you're going to find or simplify the most furthest away from this R equivalent sign. If the sign shows you like this, then you need to try to solve it from the furthest away from these terminals A and B. Okay, furthest away. I shut the jam. Okay. Yes, you can go to this link and then go to Jamboard. Please scan the QR code. Let me check your attendance. 32 response. Okay, good. You have to use your Gmail. By the way, I'm confused why this morning I download your attendance from the database, but only 15 shown in the class. Maybe there's something wrong with the system. Only 15 people in this class. And luckily I have your name before they changed it to 15. Last time it was like 52 people. Only Nadi, Zal, Aiman, Hana, Miza, who else? Haris, Raid, then Shiham, Muiz, Irdina, Maizato. I think these names, maybe you guys already update your email, right? Because I saw all with 2 emails. For those who are not updating the emails, maybe the system will not show up. This one, maybe I need to reconfirm why they show only these names. It's supposed to have like this 50 something, 52. Okay. Right, tak apa. Go to QR code and then scan. Scan for your attendance. And nobody volunteer in this Jamboard. Please volunteer. You're going to simplify. Remember, if we have circuit in parallel, it should be end-to-end mix, right? Something like this. This is a parallel. Okay. If you have in series, then it should be side by side. Okay, this is series. What if I have a resistor in parallel with a short circuit? What do you think this R equivalent will be? If this is A, this is B, this is R equivalent you're going to find. What is the value of R equivalent? This is like a pop quiz. What do you think? By looking from this side, from left to right side, can you see it? I hope so. From left to right side, what do you see? This part. What is R equivalent? Any volunteer? You can unmute yourself. Brothers and sisters, do you have quizzes after this or quiz?
Yes.
Oh, no wonder. Okay. What quiz? Drawing?
No.
Statics.
Statistics.
I think statistics almost every week, right?
Yes, every 2 weeks.
Yes.
Oh, yeah, lovely. I shall give you also. something. By the way, if you look at the assignment, the first assignment, it should be in this week, right? So maybe I will give you in this week for the assignment. Maybe during your holiday. This week we have one holiday, 1 day holiday. Nuzul Quran on Thursday, if I'm not mistaken. And then maybe you guys can do the assignment. Is it okay? Or maybe during the class time. If I give you the class time, then you don't need to spend your time thinking on assignment, right? And put it as a attendance. Okay, tak apa, tak apa. Later we discuss on that. So what is R equivalent equal to if we have resistance in parallel? I hope you can focus because this one, maybe we will stop like 1 hour only for you guys to have that quiz. Yeah, you can prepare for statics quiz. So what is R equivalent? Maybe you should focus and then we can finish early our class. I maybe will give you this as a quiz or assignment. So better you do understand this. What do you think? R equivalent equal to what? If I give you the first one here, maybe R1 and R2. So what is R equivalent?
R1
Anyone?
inverse plus
R1
R2
inverse. Okay.
Inverse.
Plus R2 inverse and then
inverse all.
inverse all. Just that. Or we have another R.
No.
No, are you sure? We have like 3. We have 1. Yeah. There's one branch here. Yes, I know. This is one branch. Another branch here. And although this is not like a branch, right? It's a wire. But remember something? A true wire has R equal to what? A true wire has R equal to? Because they are all in parallel, so you need to figure out what is R equal to. What do you think? Volunteers? Do you remember this?
R equal to 0.
Yes, good. This one. Yeah, we have this example, right? Last time, if we have R, if this is a R, we make it small as possible, such that R is equal to 0. Then this one will act like a short circuit here. Okay. So R here obviously equal to 0. So what do you mean by what we mean by this is actually R1 inverse plus R2 inverse plus R0 inverse. So what is that equal to? R equivalent equal to R1 in parallel with R2 in parallel with R0. So anything in parallel with 0 is actually, if you apply that rules, is like this, right? Although I don't like this, but this is the fastest way we can find the answer. So this is equal to
0.
Yes, anything multiplied by 0 should be 0. So yeah, I know this one should be like this. 3 inverse and inverse everything. And this one you get 0. So please remember, you don't need to calculate, but anything in parallel with a true wire like this, the equivalent resistance should be equal to 0. Okay, this is nothing to do with our example here. But it's just that I want you to do understand what if we have something like this, a true wire connected like this. And then what do you think? This one should be anything in parallel with a true wire will be equal to 0. So which one is in parallel with this wire? What do you think? Which one? This 60 and then oops, apa alih tu? You can press undo on the left side up here. It will undo your work. Okay. Siapa unicorn tadi tu? You can press that. Apalah. Let me just move it. Okay. Okay, something like this. So anything parallel with that will be equal to 0. So meaning to say 60 is in parallel with this wire. And then these two also in parallel with this wire. And this one also in parallel with this. So if you put a wire like this, then over here will be shorted. Some R equal to 0, R equivalent equal to 0. But since we don't have that, so I just remove everything. Okay, remove everything, and then you can solve this easily solve this. Okay. All right. Brothers and sisters, anyone who's going to volunteer this? Calculate the R equivalent. And your objective is to find R equivalent over here. Okay. After that, you're going to find I naught here. Okay. And this is the R equivalent. Which one is in parallel? Yeah, you want to say something, right? Which one is in parallel? Is the 60 and 80 parallel?
No.
No, okay, good. And then is the 20 with 6? Are they in parallel?
No.
It's no. So which one is in parallel? 6 and 20, are they in series?
Yes.
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 You sure? 6
No.
20, are they series? No. Why not?
Oh.
Why not?
Because
Because, yes, because
no, no.
because you have another branch here and here.
Branch.
So
Yes.
please be careful. They are not in series. So which one is in parallel then? Go back to your theory. End to end should meet, right? So which one have that two ends meeting to each other? So which one?
15 and 20.
15? 15 and 20. This one and this one. Are they in parallel? This one, yes. This end meets. But what about this one? No, right? There's something else here. So they are not in parallel. It's supposed to have like meeting one through wire here. So this and this are not parallel. Okay. Any other guess?
12 and 6.
15 and 16.
Yes, 12 and 6 are in parallel because this end meets and this one also meets. So this one you can combine. Okay. And other parallel circuit?
20 and 80.
20.
Yes, this part. Okay. So you can write down the equivalent circuit. This 12 and 6 are in parallel. And then what about this part? This with this. What do you think?
Yes. In
Yes.
parallel.
Yes, what? In parallel, right? So, parallel. Kejap. This part and this part. Connected to one single line here.
Series.
Yes, series.
Two
Side
line of
by side, right?
parallel.
Side by side. So you have series can be added. So you can plus there. All right. And then what else? Now you can simplify this into, this is 15. And then you have this equivalent. And then you have the last one, 60. Is this correct or wrong? What do you think? The whole thing here.
Yes.
Yes. Okay. Is there any parallel circuit in the circuit over here, down here? Parallel or series?
One series, one parallel.
Which one is in series? Which one is in parallel?
5 and 15.
In
5,
what?
15.
5 and 15 are in series or parallel?
Yeah, series.
Series. Okay. The hint is you need to solve furthest away from these terminals. Okay. This terminal A and B. Try your best to solve from furthest away from the terminal AB. So mean to say you can start from 60. All right. 60 and then you go to this side. And then you go this side. So you simplify until you get this equivalent. All right. So in fact, 5 and 15, they are not in series. Because why? Because they have another branch here and then branch here. The 5 here will be, the current flowing through 5 here will branch out to 1 here, 1 here, and 1 here. So you're supposed to solve this part first, and then you solve the rest. Okay? So which
Okay.
one is in parallel and series?
The 12 parallel to 6 plus 8 parallel to 20 is parallel to 60.
Yeah, good. So you have this one in parallel. Let me put it this way. This is in 60 and this one with 15. Okay, and this is equal to R equivalent. Okay, everyone clear or still not clear?
You made them.
Yes, okay, good. So you can solve this. Can you use your calculator? Yeah, try to find this. 12 and 6, what do you get? 12 parallel with 6. What do you get? I want you guys to try use your calculator, your 512 calculator. The model is 512. By the way, you're supposed to get the sticker if you're going to have a physical exam in the hall. You need to get your sticker from DDAA office, and then they will give a free sticker just to check that one is a valid calculator to enter the hall, the exam hall. So, okay. And then you must know how to use your calculator. So how to use this? First, you can do like 12 inverse plus 6 inverse, and then inverse everything. And you get this part. Okay, and then plus, you have 80 inverse plus 20 inverse and inverse everything. And you will get this part, right? Then after that, what do you get for 12 and 6? This part? Anyone?
4.
Okay, 4. 80 and 20?
16.
16.
15 or 16?
16.
16. Okay, so this is 20. Okay, I will just write down 20 down here. And then this is 60 and then 15. Okay, what do you get for this side? 15 inverse plus 20 inverse plus 60 inverse and inverse everything. And we get answer. Oops. Okay. What do you get?
7.5.
7.5. All get the same answer, eh? 7.5?
Yeah.
Yes.
About
Alright.
7.5.
Okay, good. I don't have answer. Okay. Then how to calculate I note? This one you know that this is 40 volts here. And then how to get I note? I note is in series with 5, I note will flow through 5 ohms and 7.5 resistor here. And then return to this negative polarity. Meaning to say the same current will be flowing through all resistors, right? And 5 with R equivalent, yes, you can add. Either you use KVL around the circuit. If you use around KVL around the loop here, then you will get negative 40 plus 5 I note plus 7.5 I note equal to 0. Then you can rearrange, you get the answer. But if you use another method, which is the Ohm's law, because right now we stay in basic law, right? Basic law have Ohm's law, KVL, KCL. Still remember, right? Voltage divider, current divider. So all these 5. Okay. So Ohm's law, if you have a Ohm's law, V equal to IR. Then what is I naught? V, which is 40, divided by R. Because R are in series, so you can plus both. And then you get answer. Okay, you can compare. Do you get the same answer or not? I naught is equal to 40 divided by 5 plus 7.5. Do you get the same answer? 3.2?
Yes.
3.2, okay.
Yes, madam.
Yeah.
Okay, good. Since all agree 3.2, then that's the answer. Okay. Done, eh? Okay, alhamdulillah, done. This one also done. Okay. Okay, I think that's all for chapter 2. Do you have any question before we go to chapter 3? Or do you want to stop here?
No, madam.
No, eh? No. Sana saya cari.
Ikut madam.
Ikut madam. Okay.
Kalau madam
Madam lah. Tak apa je. Sekejap. Okay. Okay, we will look at chapter 3. Try your best now not to mix up chapter 1, 2 with chapter 3. Chapter 1 and 2, they are basically basic law. And basic law always have like that 5 rules, the KVL, KCL, the Ohm's law, the voltage divider and current divider. Okay. But for our chapter 3, we have method of analysis. There's some method which apply the nodal and the mesh. Mesh basically the loops. Nodal means the node. So we already learned this in our chapter 2. If we have branches connected at one single point like this, then we can apply some other analysis, means nodal analysis. But if we have some loops, a closed loop, then we have some imaginary current inside, then we can use mesh analysis. So basically in our chapter 3, we only learn these two big method, nodal and mesh. And inside nodal analysis, you have a nodal, you have what we call it as a super node. Super node. And in mesh also, we have what we call it as a super mesh. Just put super in front of that node and in front of that mesh.
Madam,
Yes.
my friend still waiting to enter the class.
Oh, sorry. Cik baik ada orang alert. Kejap Yeah, maybe these brothers and sisters they enter very late. Then yeah, okay. Because the system will stop. They will stop admit it. Automatically admit if I present something. Right. Ada masalah juga ni, kejap nak ni saya baik saya tutup. Okay, now boleh buka. Okay. So nodal and mesh analysis. Now can we recap? What is the voltages across the parallel circuit? V naught equal to? Volunteer?
VS.
Vs. Good. It should be same, right? This one equal to this voltage equal to this voltage across the load. Okay, so same. This one is equal to V naught. V naught is parallel with circuit across this load. Okay. So what effect does the resistor has on the current flowing in the circuit? What effect does the resistor here has on the current flowing in the circuit? Okay, we know that this Vs will have a current source, and this current source will branch out to I1, and then we'll branch out to another one, right? I1 and I2. And then we know that this Is is actually equal to, since they are branching out, so they should have I1 plus I2, which is equivalent to Is, right? Okay.
Yes.
And then what do you think if we increase the R value? If we apply here, maybe I should put in terms of Ohm's law, V equal to IR, okay? And then we know that voltage is equal. Ada lagi baru masuk. Okay. Tadi apa kita buat? R Okay, R.
V equal to IR.
V equal to IR, alright. If we increase R, what happened to the voltage?
Increase also.
Increase too. Yes,
Increase also.
So you just play around with this. You have I1R here and plus I2R. Oh, ni apa saya buat ni? Sorry It's supposed to have Vs equal to V1 equal to V2. And then V1 here, you have a I1 R1 and equal to, better not to put this. And this is I2 with the circuit load. R load I just put R load here. This is R load. Okay. And this is Vs. So meaning to say, if you increase this, the voltage here also will increase. And what happened to the current? Current will
Increase.
decrease, right? Because of
Decrease
Decrease.
current will decrease. So if
depending on the resistance.
So if we decrease this current, I1, then what happened to I2? What do you think?
Decrease.
Increase.
Increase. Because when this one become lower, this one will become higher. So this plus this will get this answer, right? So we can play around with the rules of parallel. And you need to know that voltage across all should be same. And you need also to know that Ohm's law also can be applied here. So what effect does the resistor has on the current? If you increase R, then voltage will be increasing. And if you increase R, current will be decreasing. But if you decrease the R, yes, voltage will be decreasing. So you can relate with I2 also. So when I2 is increased, then the R here will be decreased, the R load here. Okay, you just play around with the terms and then you will get the answer. Because I think if you look at your textbook, there's a question on something like this. What happened to this when this one happened? Or what happened to this when this one apply, or increase or decrease? Okay, what is I naught in this series case? What do you think?
S.
Equal to, yes, equal to IS. By the way, this one should be in not capital letter, a small case, because they are not in AC form. So it's supposed to be a small letter. Okay, what effect does the resistor has on the voltage seen by the circuit? Voltage seen by the circuit. Voltage seen. No. It's supposed to be this way. Voltage seen by the circuit, or like this. This is a voltage. What effect does the resistor, meaning to say we still have this R load, right? So what is this equal to? We know that I naught is equal to that IS. So we just put I naught. And we know that I naught is equal to IS from here. And then apply the Ohm's law, we have this. So if we increase our load, what happened to the voltage here? Voltage across this load, the circuit load.
Increase.
Yeah. And then what happened to the current?
Decrease.
Decrease.
So this is the relationship, right? And if you want to have an equivalent circuit, you can have R here and here. Because they are in series, you can plus both R plus RL. We have the R total. Okay. Okay, this one, the terminology here, this one, I think you're familiar with this, and this. And mesh, yes, is a loop that does not enclose any other loops, meaning to say loops that is not depends on other loops. It's a independent loop. Okay, a mesh is a any closed loop that does not depend on other loops. As long they are closed, then they are a mesh. Okay, this one, okay. What about planar? Okay, a planar is a circuit that can be drawn on a plane with no crossing branches. Meaning to say, if you have, this is one, jump pelik je. As long they are not cross each other, then they are planar. A circuit that can be drawn on a plane with no crossing branches. This one is straightforward, right? Is there any crossing branches? What do you think?
No.
If I draw another one here, it's still a planar, right? Planar.
Yes.
Okay. What happened if I put, macam mana nak buat 6 planar Kejap saya dah pening. Something cross something. Okay, if I draw like this, do you think this is a planet or not? Makin kecil sorry Nampak tak?
No.
No. It's still a, wait, this is a planet or non-planet?
I think not.
A planet or not?
No, I think.
No.
Maybe no.
Okay, let me redraw this one. If I change the color to, let's say blue. And I just move this one. This is connected to here. And I put here. Then put it at this end. And this is the same circuit. And I just remove this one. Yeah, right. Now, is it a planar or not?
Yes.
Yes.
Yes, still a planar. Okay. So this still a planar. So what is a non-planar? Non-planar is when you have a crossing branch. Let's say I put this one. Is it a planar?
No.
You can still move this one to here,
Yes.
right? So still a planar circuit. Still a planar circuit. Then how to give a non-planar circuit? Anyone can guess? It's crossed to each other. When you adjust, it's still crossing. Macam mana? It's actually in your textbook with example, tapi I don't have that. You can open your textbook and it's basically if you move around, it's still cross. You cannot move around. Macam mana ya?
Like the circle have to be in square, madam.
Huh? Come again?
Like the like rectangle needs to be the clean circle. Macam ni.
Oh, clean circuit. Okay. But
Dia sambut dia. Dia kena cantik je.
yeah. Okay, maybe I will just open the textbook, right? Mana textbook? Textbook. Download. Textbook. Keluar pula. Sekejap. Where is it? Last time saya letak dekat download. It's supposed to be in the download. Ada lagi yang baru masuk. Satna, I'm sorry. I will take your time. You can open your textbook and then try to flip around. What is the page for that? Kat mana saya letak ni stuff nak sini. This transmission. Download I think. Desktop. Okay, then this one. Yes, textbook. Banyak sangat file macam ni lah. Not this one. Saya rasa dalam download kot. Kalau tak saya kena buka dekat your ni kan. Okay, good. Open chapter 3. Okay. Alright. Do you think this is a planet or not?
No.
No. Why not?
Because they are crossing
Crossing, right?
each other.
Okay, let me draw this 7 ohms. If we put it here, this 7 ohms, then we put it this way. Okay, this one cross. So if you put it up here, also cross here. So there's no way you can move this because they are crossing. So this is a non-planar. Okay, the normal one is a planar. So clear, right?
Yes.
This one also, what is this one? A planar or non?
No.
A non-planar. Okay, a non-planar. If you put it this way, it cross here. This is a 3 ohms here. Okay, I hope you do understand that. So maybe can we stop here? Because it's almost 11. Or do you want to continue? I'm okay.
Stop here.
Stop here. Okay. We stop here and then try your best to do your homework revision for chapter 1 and 2, because in our next class I will give you assignment and then try to finish it during the class time so that you don't have any assignment to work at home or at your room. Okay. Okay, with that we finish our class with tasbih kafarah and surah al-as. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Al-as innal insana lafi khusr. Tawasul bil haqq wa tawasul bis sabr. Alhamdulillah rabbil alamin. Okay, please scan for those who just come. Please scan and then fill up